Now I want to take a look at some examples trying to apply each of the theorems that we've covered. On problems 1 through 3, it says find the sum of the measures of the interior angles of the indicated convex polygon. So an octagon, and maybe it's helpful if you try to draw something out, if it helps you visualize things better. So an octagon, like a stop sign, I want to find the measure of the sum of each of those interior 8 angles. So the number of sides, n, is 8 for the octagon. I could use the equation or the formula n minus 2 times 180, not just for numbers 1, but numbers 2 and 3 as well. So 8 minus 2 is 6. 6 times 180, the sum of the interior angles of an octagon, 1,080. Okay. I'm going to extend that question a little bit. If I have a regular octagon, for example, a stop sign is a regular octagon. If I wanted to find the measure of each interior angle, such as this angle right here, I don't know, maybe I'm going to design a stop sign or something, or just make like a replica for whatever reason. But to find the measure of each interior angle, now I could take that 1,080, that's the sum of all 8 interior angles, divide by 8. So the measure of each interior angle is, I'm just going to call this angle 1, measure of angle 1, that regular octagon, 135 degrees. Again, 1,080 divided by 8. Then on number 2, if I want to find the measure of the sum of each of the interior angles of just a 15-gon. 15-gon has 15 sides. I'm not going to attempt to try to draw that, but to find the sum of the interior angles, 15 minus 2, that's n minus 2, times 180. That's the equation or the formula that you would use. So 13 times 180, the sum of the interior angles is 2,340 degrees. Okay, I'm going to skip to numbers 4 through 6. The sum of the measures of the interior angles of a convex polygon is given. Classify the polygon by the number of sides. So we really need to figure out the number of sides of the polygon if the sum of the interior angles is 900 degrees. So here's what we could use. This equation or formula, n minus 2 times 180 is equal to 900. This is the sum of the interior angles. The sum is given. We want to figure out n, the number of sides, and then just name the polygon. So in order to solve this, here's one way that you could solve that problem. I could distribute the 180 to the n and the negative 2. That's one way. Or I could just start off by dividing each side by 180. So 900 divided by 180, that gives me 5. So then on the left side, these will cancel out. N minus 2 is equal to 5. And then solve this for n. Add 2 to each side. N is 7. A 7-sided polygon is a heptagon. And then you just do the same thing for numbers 5 and 6. I'm going to go over number 6 in a minute. Pause the video, see if you can work through that. So for number 6, here's what you should have come up with. The number of sides of the polygon is 18 by using the same formula that we used for number 4 and solving it for n. So an 18-sided figure is just called an 18-gon. And then for number 7, it says find the value of x. So you're given the measure of 3 of the interior angles of a quadrilateral. You want to find the measure of the 4th interior angle. If you take a look at your table or just use the equation or formula, the sum of the interior angles of a quadrilateral is 360. So I could set up the equation x plus 65 degrees plus 95 degrees plus 45 degrees is equal to 360, and then solve that for x. There's an equation that you could use, adding up all 4 of the angles, the interior angles of the quadrilateral. The sum is 360. You can combine the like terms by adding up the 65, 95, and 45 to get 205. Subtract that from each side of the equation to get x is 155 degrees. I think it's somewhat to scale here. This looks like about a 45-degree angle. This looks like about a 95-degree angle, a 65-degree angle. So 155, this is definitely an obtuse angle. 155 is obtuse, so it really does check out there.